Let's explore Python iterators. We'll focus on understanding and implementing the Iterator Protocol. To begin, examine this code snippet. We are iterating through a list named numbers, containing the values 1, 2, 3, 4, and 5. The for loop prints each number in the list. So, what exactly are iterators? An iterator is an object that holds a countable number of values. It implements the Iterator Protocol, which includes the methods ___, iter__, and __next__. Here are some key characteristics of iterators. First, they can be traversed one element at a time. Second, they maintain an internal state during iteration, remembering where they are in the sequence. Third, they raise a StopIteration exception when they've exhausted all the values. And finally, they enable memory-efficient data processing as they load data on demand. The Iterator Protocol is central to how iterators function in Python. It consists of two essential methods, ___, iter__, and ___next__. Let's start with ___, iter__. This method returns the iterator object itself. It's required to make an object iterable. You typically use it to initialize the iteration state, setting up any necessary variables. In this example, we initialize the current attribute to 0 and then return self. Next, let's look at ___next__. This method returns the next item in the sequence. When there are no more items, it raises the StopIteration exception. Inside this method, first we check if current is greater than or equal to self.max. If it is, we raise StopIteration. Otherwise, we store the current value, increment current by 1, and return the stored value. Python has several built-in iterators that make working with sequences easier. These can be grouped into collection iterators and generator iterators. First, collection iterators such as list, tuple, set, and dict. All built-in collections in Python are iterable. This means you can loop through them directly using a for loop, as demonstrated here with the numbers list. Next, enumerate. Enumerate returns index and value pairs, allowing you to easily access both the position and content of each item in a sequence, as shown in this example with the fruits list. Now for the generator iterators. First, range. The range function generates a sequence of numbers. It's often used in loops to repeat actions a specific number of times, as you can see in this example, which prints numbers 0 through 4. Next, zip. The zip function combines multiple iterables element-wise. This is useful when you need to iterate over several sequences in parallel, as demonstrated here, where names are paired with ages. Creating custom iterators in Python involves a few key steps. First, create a class that will serve as both the iterable and the iterator by implementing the required methods. Next, the __iter__. Method must return the iterator object itself, which is usually self. Then the __next__. Method returns the next value in the sequence. Finally, raise StopIteration when the iteration is complete to signal the end. Let's look at a custom iterator example. Here's a countdown iterator. This custom iterator counts down from a specified number to 1. Let's look at the code. We define a class named countdown. In the __init__. Method, we initialize the start attribute. In the __iter__. Method, we initialize the current attribute to self.start and return self. In the __next__. Method, we first check if self.current is less than or equal to 0. If so, we raise StopIteration. Otherwise, we store the current value in value, decrement self.current by 1, and return value. The iterator maintains its state with the current variable, allowing it to keep track of the countdown's progress. StopIteration is a built-in exception that signals the end of the iteration sequence. When an iterator is exhausted, the __next__ method must raise this exception to tell Python there are no more items to return. Let's look at an example. We create an iterator my_iter from my_list. We then manually iterate using a try block and the next function. Once all elements are exhausted, calling next raises StopIteration, which is caught, printing the message iterator exhausted. It's important to distinguish between an iterator and an iterable. An iterable is an object capable of returning its elements one at a time. It implements the __iter__ method, and examples include lists, tuples, dictionaries, and sets. It can be used in a for loop. In this code, the list numbers is an iterable, and we obtain an iterator iter_obj from it using the iter function. Now let's talk about iterator. An iterator is an object representing a stream of data. It implements the __next__ method, maintains internal state during iteration, and raises StopIteration when exhausted. In this code, we are using the iterator iter_obj to print the next elements. Let's look at a practical example of Fibonacci sequence iterator. This is a custom iterator that generates Fibonacci numbers up to a specified limit. We define a class named Fibonacci. In the __init__ method, we set the limit. In the __iter__ method, we initialize a to 0, b to 1, and return self. In the __next__ method, if a is greater than limit, we raise StopIteration. Otherwise, we store a in result, update a and b to the next Fibonacci numbers, and return result. Finally, we use a for loop to print the Fibonacci numbers generated by our iterator. To effectively work with iterators, here are some best practices. First, separate iterables and iterators. For complex cases, consider separating the Iterable container class from its iterator class for cleaner code organization. Next, use generators when possible. For simpler iterators, consider using generator functions, as they handle state management and StopIteration automatically. Then lazy evaluation. Take advantage of iterators' lazy evaluation to handle large data sequences efficiently without loading everything into memory. Here we process a large file line by line. Finally, error handling. Always implement proper error handling in your iterators __next__ method to ensure clean termination. Here we include error handling in the __next__ method to gracefully stop iteration when an indexer occurs. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.